Hello, in this session, we will see how to enhance API security using a gatekeeper. Before I talk about what, why, and how to use a gatekeeper, let me take a step back and talk about what is the problem and why we need to use a gatekeeper. Let's assume you created an API proxy within the API manager. So you get the instance ID and the API status is in unregistered state. Then you add an SLA tier with some requests per minute or per hour. Then you add an API policy such as a rate limiting SLA based policy, or this could be a client ID enforcement policy, or this could also be something like a OAuth policy as well. And then you go to your Anypoint Studio, you develop a simple application. And in order to map this application with the API proxy, you also configure an API autodiscovery within the application with the API ID, which you receive it from the API proxy. And within your Anypoint Studio, we also configure the API manager's client ID and client secret, and you deploy the application. So let's assume this application is deployed to Anypoint Studio, and we are checking the logs from the console. So after some time, you should be seeing a log saying that the gatekeeper is disabled. So by default, within Anypoint Studio, when you add API Auto Discovery and when you configure the API Manager credentials, the gatekeeper starts in a disabled mode. And it is also going to use the client ID client secret to successfully validate against an API Manager. And once it does this, the application will be deployed. And at this point, if some user or a client is making a call to the application on its specific port and the URL path, the application will be able to fetch the response back. And if you see the logs, even if there's any logger, so that will be executed. And after some time, the application it's going to connect with the API manager, validate itself using the client ID client secret, and it is going to download and apply the policies which were part of this API ID. And if you see, the status is also in active state once the application is deployed. So any policy which is added in this API proxy will be applied to the application. And once the policy is applied, the end user or the application who is making a call will be receiving 401 unauthorized HTTP status code, because the rate limiting SLA based policy expects a client ID and a client secret within the header by default. But here, the problem here is, before the policy was downloaded, there was a short window period where the application was available without any security. And if any user or a client tries to access the application in that window period, they will be able to access the application unsecured. So if you see here, generally the difference in time is in milliseconds, right? So it took around, I think, 400 to 500 milliseconds for the application to download the policy and apply it in the application, right? So in this milliseconds of time, if any call is being made to the application, they will be able to access the data. So this is a security lapse, and we need to make sure that no data is accessible during the policies are added or when the policies are being applied. So this is the place where the gatekeeper comes into the picture. So why use a gatekeeper? When you deploy an application, the tracked resources exposed by the application might become accessible for a short window of time due to a lapse in security. Because the policies for these resources are not yet downloaded and applied, the API might receive unwanted or unsecured traffic. So what is a gatekeeper? So a gatekeeper prevents the situation by blocking the tracked resources until all the policies are retrieved and applied without errors. And how does a gatekeeper help you? So gatekeeper is a mechanism which is engaged only when you are restarting the runtime or redeploying a tracked resource that is linked with an API instance. When engaged, the tracked resources is blocked, resulting in a 503 service unavailable HTTP status code. And you're going to get 503 service unavailable until all the policies are applied in the API manager without errors. we can enable or disable gatekeeper functionality using a custom property value like anypoint.platform.gatekeeper equal to the security level. So it has three different modes. It is disabled, flexible, and strict. So we will talk about these modes in detail in the next session. And what is the default Gatekeeper configuration Cloud Hub? So it depends on the runtime which we are using. So if you're using a runtime of 4.0.0 version, so by default, it is going to use the strict mode. And if you use a runtime of version 4.1.0 and later, it's going to use the flexible mode. And in Anypoint Studio, by default, when you deploy an application, the Gatekeeper runs in a disabled mode. So let's take an example. So in the previous slide, we saw how the end users can exploit the application during the policy application time. So how can we avoid this? So within Anypoint Studio, we can start the application by passing it an VM argument like anypoint.platform.gatekeeper is equal to strict. So when you pass this argument and deploy the application, so within the logs, you could see that the gatekeeper started in strict mode, and it also validates the client ID and client secret against the API manager. So now what happens? Since we are starting the gatekeeper in a strict mode, you should see that a policy gatekeeper gets started, and it's going to deploy the application. So once the application is deployed, if any user tries to access the application, or if any client tries to access the application on its URL, so they will be receiving 503 service unavailable HTTP status code. The reason is, now since the gatekeeper is in strict mode, it won't allow the application to send any responses. So it's going to block the API, right? And any calls which are being made will result in 503 service unavailable. So in the meantime, the application will download all the policies from the API manager and successfully apply them. And once applied, it is going to also log a message saying that the gatekeeper is shutting down. And once it is shut down, it also sends a log message saying that this API is now unblocked. So once you see the API is unblocked, any calls which are being made or any calls which the application receives after this log message, it is going to apply the policies which are downloaded, and hence if the user doesn't send any valid credentials within the request, they will be receiving 401 unauthorized or any other message based on the policy which was downloaded, right? So if you see the difference here from the previous slide, the users will not be able to access the application data. It is going to be secured because the gatekeeper will not allow any calls until all the policies are downloaded and applied successfully. So in the next hands-on session, so we'll see how this is going to work, and we'll also see what is the difference between disabled, flexible, and the strict mode. That's all for now. Thank you.